Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Hisyammuddin bin Ahmad. My final year project title is Measuring the Number of Cycles for Low Cycle Fatigue Material SA213P91 in Water Tube Steam Boiler at room temperature. My supervisor is Professor Dr. Muhammad Hussain Ismail. For the project summary, this project involves the study of fatigue condition of material SA213P91 in a water tube steam boiler at room temperature. Power plants have been playing an essential role in generating vast amounts of electricity or processing raw materials to become products. The machinery operates at elevated temperature with some vibration caused by its surroundings and is exposed to low cycle fatigue (LFC) stresses. Based on thermodynamics, raising the operating temperature of a power plant is a primary technique to increase its energy efficiency. However, high operating temperature require outstanding structural integrity. Material grade P91 is exposed to elevated temperatures, which usually involves thermal fatigue. The fatigue condition this material at room temperature is required to be known as the basis of further studies at elevated temperature. The main cause of forced outage in coal-fired thermal power facilities is boiler tube failure. Power plants must produce electricity without forced outages in order to keep up with the rising demand for electricity. The efficiency of the boilers is the foundation for power generation in a thermal power plant. Power plant must provide electricity without interruptions to keep up with the world's rising demand for electricity. Boiler tube leakage is a problem that power plants are now experiencing, and it becomes more serious when they are operating at full capacity. It now ranks among the many important causes of the energy crisis. Utility companies have long battled boiler tube failure. Due to the generating loss caused by the tube breakdown, millions of dollars were lost. Boiler tubes have a finite lifespan and are susceptible to a few failure modes. In boiler, tube failures are categorized as in-service failure. These failures can be grouped under six major causes: stress rupture, fatigue, corrosion, erosion, material failure, and welding defects. Material SA213P91 is commonly used in a boiler application, specifically on superheater tube and superheater header parts of the boiler, which always operates in high temperature. However, high operating temperatures require outstanding structural integrity. Material grade P91 is exposed to elevated temperature, which usually involves thermal fatigue. The fatigue condition of this material at room temperature is required to be known as the basis of further study at elevated temperature. The objective of my final year project is to get the number of cycle to failure of the material SA213P91. Next, to get the tensile strength of the material SA213P91, and finally to get and study the microstructure of the material 213P91. Next is for the methodology. The first one is literature studies. The objective of literature studies is to synthesize and evaluate any arguments and recent information related to any specific topic and scope without making significant contribution. The literature studies for my final year project have been included in my proposal report. The second one is preliminary experiment. Some preliminary experiments have been carried out during this final year project 1, such as sample preparation, microstructure analysis, and hardness test. Next is the tensile test. tensile test is a destructive test process that provides information about the tensile strength, yield strength, and ductility of the metallic material. The next one is fatigue crack initiation. The objective of fatigue crack initiation testing is to determine the initial cracks grow under cyclic loadings prior to reaching a size critical for fracture. And the last one is fatigue crack propagation. The objective of fatigue crack propagation testing is to determine the rates at which the subcritical cracks grow under cyclic loadings prior to reaching a critical for fracture. The tensile test and the fatigue test will be carried out during FYP2. Next, for the preliminary experiment that I have carried out during this FYP1, before carrying out the experiments such as microstructure analysis and hardness test, I have to do material preparation of the specimen. The first process of material preparation is cutting. The specimen was cut using abrasive cutting machine. The next process is grinding. The specimen next went through grinding process. There were 5 levels of grinding process using 5 different sandpaper, which is 240, 320, 400, 600, and 1200. Each level take around 30 to 45 minutes. The next process of material preparation is polishing. The specimen will be polished with 3 stages with 3 different polishing powder to make sure the surface is more glossier and more noticeable. The last process of material preparation is etching. The etchant used is scaling number 2, which consists of 60 ml of ethanol, 2 grams of copper chloride, and 40 ml of hydrochloric acid. This is the picture of the specimen before and after material preparation. As we can see, the specimen surface has become mirror-like after all the material preparation processes, which is cutting, grinding, polishing, and etching. After all the processes of material preparation is done, the first experiment that I've carried out is microstructure analysis. These were the result of microstructure analysis under the lens of times 50 times 100 and times 200 of the microscope. The result of this preliminary experiment will be used to compare with the microstructure analysis for the specimen after the tensile and fatigue test that will be carried out during the FYP2. The other experiment that I have carried out during this FYP1 is the hardness test. The method of the hardness test is Vickers hardness test. As we can see at the picture, this is the hardness test machine and the sample result of the experiment. I have done 5 times of the experiment and get the average value for the Vickers hardness. These were the result of the hardness test. The result of this preliminary experiment will also be used to compare with the hardness level for the specimen after the tensile and fatigue test that will be carried out during FYP2. That will be all from me for my FYP1 presentation. Thank you very much.